We still have a major issue in the game that we're making to learn Unreal Engine here, and that is we have a way to kill the character when it falls below a certain amount of depth in the world. And we actually do need to set that to a lower value to showcase that, but we do have a way of that because Unreal builds in our kill Z height. So if we're below that height, our actor just gets destroyed, which is quite nice because it means that if any enemies or any other objects fall over the edge of our level, they'll get destroyed and they don't constantly keep taking up resources as well. Downside being, our character also just gets destroyed. It absolutely just gets deleted out of existence. So that way of killing our character doesn't really work all that well in any way, shape or form. And there's multiple different ways that you can handle character death. You can destroy your player character and then spawn in a new one. But what games very often end up doing is instead of destroying and respawning in a new blank character to possess, it just takes your current character and teleports it to whatever place it needs to be at for like a checkpoint or something like that. So that's what we're going to be doing here. We'll make a checkpoint system that whenever we get near one, it will set up our new respawn location. And when we die, instead of destroying our character entirely, we just teleport back to that location. Now that does mean that we're not going to be using the kill Z anymore, because that just automatically actually destroys your character, and we don't really want to do that because it's annoying to deal with. That also means that we're going to need to set up our own killing volumes for when we jump off the edge of a level for us to, well, be able to die. There's a couple of steps to this, so let's get started right away by opening up our tutorial player here, our BP player character. And here I'm going to first and foremost get rid of our score printing. That's been unnecessary since a handful of videos ago. And we'll add in a new custom event, and we'll call that kill player. Eventually we'll add in more different stuff to this function as well. But for now, all that we really need kill player to do is we need to teleport to a new position. So what we'll do is we'll make a variable and we'll call that respawn transform. And that's going to be of type, well, transform. A transform is a variable type that has a location, rotation, and scale all just smushed together into one variable. It's quite nice. So whenever we kill the player, all we need to do is set the actor transform to whatever our respawn transform will be. So that's going to set our actor's rotation, location, and scale to whatever we told it. Okay, this is going to be your respawn point. And there's not that much more to it. Eventually, this will also probably include things like playing an animation, waiting for the animation to end, probably popping up with a UI element, and then the UI element waiting input from the player, and only then doing this stuff. But we'll get to that sometime later on. For now, this is the basic functionality that it's going to have. We need to give the respawn transform a default value though, because by default it's going to be 0 in everything. Well, 1 in the scales, I suppose. So on begin play for our character, we set the respawn transform, holding an Alt and just dragging it into the event graph for a setting node. And we also, every actor has this get actor transform node. This just gets you the actor's current transform, its location, rotation, scale, and we can put that into this variable so that we remember, okay, when we started playing this level, where are we looking, and how big are we? Then the checkpoints will just overwrite this value whenever we reach a checkpoint. So by default, if we now say kill player, which will also just assign a debug key for, let's say, K for kill, surely somewhere in here, debug key K. When we press it, we'll also just set the actor transform. If we walk away a little bit and we press it, we can see that we instantly snap back to our previous location. Just like that. So that technically just straight up already works. Now we need a way to actually run that, to actually kill the player. And for that, we're going to make a custom killing volume. So in here, just in, I don't know, level props, we'll add it. Make a new blueprint class. It's going to be a basic actor, which will be BP kill volume. And all that this kill volume is really going to need to be is a box collision, and that's it. What you can do is, just for the sake of making things clear in editor, is add a billboard component as well. A billboard component is just a component very much like these things that you see here. These are just images that always face the camera, and they're usually reserved for being editor only. They're usually hidden in game. They don't need to be, but usually they are. And they help you just seeing at a glance in the editor, hey, this is this type of object. Here the trigger has a billboard to show you its icon. The sequence player has a billboard to show you the icon, and so on and so forth. So you can add in any arbitrary sprite here to show you, okay, so this is this type of thing. I don't think by default we have like a death or like a skull or whatever for death volume. So we'll just add in, I don't know, this icon for show skeletal meshes. It's just a placeholder, really. We could go and make an image for this. So just in here, like add a quick ellipse with just some extra detailing to make it a skull. It's going to be really ugly because I'm just kind of eyeballing everything about this. So this will be our very ugly skull. I'm just going to add this as an image in the project download folder as well. So I'll make a new folder here, editor files, and that's where we're going to put that PNG. So just import that PNG, and that's what we're going to be using here instead. It's going to be a little bit bigger than the previous one, but now we have an image for our kill volume. So fantastic. So then we can start scaling this to be as big as we want or need it to be. You could actually change the box collider itself instead of changing the scale of the actor as a whole, which might technically be a little bit better to do. But personally, what I end up doing is I just set this to like 250 by 250. So it's kind of huge, and then just kind of pull it down to below the rest of the level. Now we have a pretty simple but effective kill volume. All we need to do is now in the event graph for this thing is when we collide with another actor, we cast to our BP player character. And we're doing a casting here instead of just doing a checking equal, because we both want to check if we're obviously overlapping with the player character. But we also need to access something that is specifically added in the BP player character class, because we need to access being able to run the kill player event. So that's why we need to upgrade this generic actor reference to our player character type reference, because now we can kill the player. And that will show you if we jump off just as easily as that, we will respawn back at the start. Now, as a failsafe, if you somehow manage to jump outside of this range and you still do fall all the way down and get killed by the kill Z height, we can build in something that when we get destroyed, we also just get set back to our original like respawn position, just as a bit of security. You shouldn't need to rely on that, but we can, because we have all of these events here. Event begin overlap, event begin play, we had event tick. There's a bunch more events that just by default exist on actors. So if you click on the actor self here in the components, and you scroll all the way down, you get a list with a lot of very useful different events that just exist on either the character, the pawn, or the actor class, just pre-made for you to use. Things like being clicked, or, well, the begin and end overlap events. One of which is on destroyed. When this actor gets destroyed, we can bind an event to that. It's not an event like event begin play on its own. What we need to do is we need to bind an event to that trigger, that event dispatcher, as they're called, a special type of variable that we have an entire section for down here. And an event dispatcher is effectively just something that is able to say, hey, a thing, a specific thing that I am designed to warn other objects or things within this object about has just happened. In this case, Unreal just itself, when it destroys an object, it calls an event dispatcher called onDestroyed. And we can link up events to those event dispatchers such that when onDestroyed is being called from Unreal's underlying code, our own code runs in response to that. That's what these event dispatchers do. That's what this binding does. You can do that with your own made event dispatchers, and sooner or later, we definitely will get through to doing that. But some of these pre-built events run off of that concept of binding to an event dispatcher rather than just being an event that exists as like its own standalone node like these ones. And binding that happens in our execution flow. So in this case, we will just do that on begin play, is whenever we get destroyed, we just spawn in a new version of this actor. So we have begin play here, we set our gravity scale, we set our respawn transform, and then we bind whenever this thing gets destroyed, it will run whatever is in this event. And what's in this event will be a spawn actor from class. And this is how you dynamically spawn in actors during gameplay. It's with this node. You give in a class the blueprint that you want to spawn in, you give in the spawn transform, and you actually have the potentiality to also add in extra data that you want to give in whenever you're spawning something. Again, something that we'll probably look into in the future. So the class that we want to spawn is just this BP player character, right? So we want to spawn in BP player character. And that works well enough. But if at some point we want to make other more specialized blueprints of this one, other child classes, like we've kind of been getting into doing slowly but surely a little bit, this is always going to spawn in specifically a BP player character. What we actually want to do is whatever child class of this BP player character is being used, we want to spawn in the exact same type as that, right? So what we can do is we can get a reference to self. This is just a reference to the object itself. So every single object when running this node will just generate a reference that points back to itself. It just kind of does the same thing as this get actor transform. This node can take an input to get the transform of any actor reference that we want to be able to give into it. By default, it just populates it with a reference to itself. This would do the exact same thing. This self is just always a reference to the very object that is running the code. If this block had any code, a reference to self would specifically point at this block. If this block did it, it would specifically point at this block. It's not pointing at a blueprint. The blueprints are just, well, a blueprint. It's just the rules of what an object can be. But the blueprint itself isn't a existing thing in the world. When we talk about references, we talk about pointing at one specific thing that actually exists either in the world or in your project as an asset or whatever. The reference to self points at the specific thing in the world that is running this code. Because if we have two player characters, right, we can have more than one player character technically just existing in the world. We can only play as one of them at a time, but we can definitely have this blueprint existing in other places if we really wanted or needed it to. This one can run kill player on itself, and then it will kill this one. This one can run kill player on itself, and then it will kill this one. These are individual instances of that blueprint. The blueprint itself is just the rule set of what this type of object is and what it can do. Initially, it's a little bit confusing. If you kinda don't get it still, hopefully as we start using it more and more in practice, you start getting a bit of a feel for it and understanding the differentiation between a class, which is what the blueprint is, and an instance, which are what the objects, the actors in the world actually are. But now that we have a reference to the self, what we can do is we can get the class from it. And this will just get you a class reference of which class, which blueprint, the self is. So if we make a child blueprint of this, like we did in one of the first videos, just create child blueprint as an example and give this a name just for communication, player child. If a normal player character runs this code, this get class will get the class for BP player character. But since this player child blueprint that we just made can do everything that the normal player character can also do and then add some stuff on top of it, if it runs that exact same bit of code, which it can do, the class reference that it will give will not be to the BP player character. It will say, I am of type, I am the class BP player child. So if we hook this up into the spawn node, this will always spawn in the same blueprint that we are currently actually using, instead of a hard-coded, we're going to be spawning in this specific one. Now I'm going to delete player child again, because that was just for demonstrational purposes. And the spawn transform that we're going to spawn it at will just be whatever our respawn transform was when we got started here. So now, if in any way we end up getting destroyed, it will spawn in a new actor for us, just like we teleported. Still, one issue with that though is it will spawn something in, but that doesn't necessarily mean that we're controlling that actor yet. Because as we just experienced, I very much can put in as many of these as I want, and whether they are placed in or spawned in doesn't really matter, but this doesn't necessarily mean that I'm going to be controlling these characters, right? Because we have this whole setup of, we have a player controller. That's the thing that actually is what we're playing as, and that player controller can possess certain pawns or certain characters. So we are possessing our starting position character here that gets spawned in by the engine. These are the exact same type of character. These are the exact same blueprints, but we're not possessing these, so we don't control these. And if we spawn in a new actor, we're also not possessing it. We are just saying, hey, we want a new instance of this blueprint to exist there. And that's the end of it. So then we need to manually also say, hey, we want to possess this, which is fairly easy to do. We can just get the player controller, and then we can say, hey, we want to possess this thing that we just spawned. Because the spawn actor, this output, will be a reference to the actor that we just spawned. If we get the player controller and tell it, hey, this is what you're going to be possessing now, it'll just switch your control to that newly spawned actor. And we'll do all of this in response to whenever we destroy our actor. And all that code runs before it actually gets destroyed, don't worry. Taking a real quick break here to say, if you're enjoying this or finding this helpful, a way that is entirely free for you to support me, if you don't want to sign up for the Patreon, is to go down below in the description to my Steam page for my own game and add it to your wishlist. Only takes a couple of seconds to do, but it actually does massively help me out and support me making my game and the content that comes along with it. So if I now add a debug key to destroy myself, debug key, let's call it, well, still K for killing, I guess. There we go, debug key K. I can just destroy this actor, which actually will destroy this actor with all the data that we have on it, and spawn in a new default one. But it will spawn it in, and we will possess it, just like we respawned previously. So those are the two different methods that we can do, is we can just use the same character and move it back to a checkpoint, or we can set this up to spawn in a copy of itself whenever it gets destroyed, and when we die, we actually destroy our player character. Both of them are totally valid. The only thing is, when we destroy and respawn in a new one, that means that we spawn in a new default character. And the more data we start accumulating on this player, the more annoying it's going to be to have to reset all that data on our newly spawned in character as well. But if your character itself doesn't hold much data, because a lot of the player data will be either kept on either the game instance, a save object, or the player controller itself, and your character is properly made in a way that it only contains data specific to that instance of the character, such as its HP, for instance, then it might actually be easier to just delete and spawn in a new one, because it'll spawn it in with new full HP, instead of the moving method, where if you die, you also then need to manually set back your HP to being full. But if you have an inventory on your character, for instance, and your inventory is kept on the actual character instead of the player controller, it would be a whole headache to move over all the data from your inventory into a newly spawned instance. So you probably don't want to be doing that if you can help it at all. It's a bit of a style choice, it's a bit of a preference kind of thing, but these are the two main methods that you would use to handle death in your game. So now, just to complete this, we have a kill volume, we have 2 ways to die, and when we die, I want to be able to have an adjustable respawn position, which is to say, I want to add in a checkpoint. So let's go into our level props, and we add in a blueprint, actor, BP, checkpoint. When we enter this checkpoint, what we will do is we will just update the player's respawn transform. So we add in a box collision to this, and we'll just add in a like normal cube here as a placeholder. That cube we're going to just squash down kind of to be a like pressure plate type of deal. If your scale down works in this proportional way, that's usually what it does by default, you can click on this little lock icon and that lets you squish it down in individual axes, which is usually quite nice. So we'll set this to just be 1 and 1 in the X and Y, and then we'll make it just fairly thin in the up and down directions. And then this box, you can scale this with just the scale as well. Box colliders also come with this box extend, which can scale the size of this box up and down without actually needing to mess with its transform. Technically, that's what you should be doing. A lot of the time, me and almost everybody that I see using this just ends up using the scale because it is more convenient to just be able to do this with like the scale widgets. This one, right? Anyway, going into the event graph, overlap, we cast to our BP player character. And here we can do this one of two ways as well. What we can do is we can set the respawn transform from here, because again, you don't necessarily need to run the code to update information for a blueprint inside of that blueprint itself, right? As long as you have a reference to a specific type of object, you can run almost all the code that that object can run on itself from other sources as well. This checkpoint can run code on the player character. So that's a thing that you can do. Generally, you want to avoid directly like setting values, just in general, honestly, but especially directly setting values on different objects. That gets a little bit messy. So a pretty good habit to get into is instead of setting that directly, what you end up doing is you make an event specifically for that job. So we make a custom event, set respawn transform. And with respawn transform, what we can do is we can just set this value then, and we can take an input value into this. The upside is now everywhere in the game that we want to be able to update our respawn transform, we can call this instead of directly setting this variable. And if at any point we need to add any code that always needs to run alongside the respawn transform being updated, we can just add it into this event as well. And then every place in the game where we call this event from is going to immediately also run that updated code. And to be super sure about never actually directly setting this value from outside objects, because again, it's a good habit to get into doing it this way, setting up an event or a function. We'll get into functions a little bit later. They're effectively the same thing as an event. Instead of directly setting a value, what we can do is when we select any variable either in here or just click on any node that contains that variable in the event graph, we can mark this as being private. And what that means is other objects now don't have access to this. I've been saying, well, as long as you have a reference to something, I can effectively access everything and run everything that I can directly inside of this blueprint from this reference. But now, assuming that we have this compiled, we'll see that we want to set our respawn transform, and that orange thing for directly setting the variable doesn't pop up anymore. Only the event that we made for it now pops up, because this one isn't set to private, so everything can access it. Nothing can directly access my respawn transform anymore. That also means that I can't get the respawn transform, which is a little bit annoying, and that's where functions come in. Functions are the same thing as events, and a lot of these simpler things, generally what we actually do is you end up making those into functions rather than events. Because the huge upside to a function is that it can have outputs. You see this node over here, it takes a couple of things in, and then once it's done spawning in, it outputs a reference to the thing that it created. That's because this is a function node. So if we go up here into functions, I make a new function. I can say get respawn transform, and here we have the inputs for it. We don't need an input for this one, and we have outputs for it. We can make an output, and that gives us this return node, and we can say, give this a name, respawn transform, give it a type. There's going to just be a transform type. And you can add in some code here to calculate some stuff, to on the fly generate a value based on some other types of inputs or whatever values are in a couple of variables here or whatever. In this case, it's going to be a super simple function that just takes our private variable and gives it out as a value. This way, we can read and write to this variable, but just not directly. And because we can't do it directly, we are forced to use this getting and this setting function or event, which means that we can more easily build it out to do other more complicated stuff later down the line if we need it to. So what we'll do is we'll set this respawn transform to match a object that we add in here. So what I'm going to do is I'm going to add an arrow component. This is one of the uses for an arrow component that I mentioned a little bit in the past. This arrow component isn't going to be visible in any way, shape, or form while playing the game. But in the editor, it is going to be visible. So we can now use the transform from this arrow to decide at what location and at what rotation and even at what scale, if we really wanted it to, the player will respawn when they respawn toward this checkpoint. So we just compile this and we get a reference to this arrow. You can just get references to all your components by dragging them in, just like variables would do. And then we can get the world transform from this component. And we can just say, hey, that's going to be our new respawn transform. So with that, if I just pull this into the level, you see we have this arrow here, which is fine. If I just decide, hey, I jump off and I die, I respawn here. But if I've been on this little pressure plate and I jump off, now I respawn on that pressure plate. But specifically, I respawn at wherever this arrow is. If you double click a component on a actor, you'll actually start moving the component individually instead of the actor as a whole. So let's say that I actually want, if I set to this checkpoint, I want to respawn here for some reason. I don't know why you would do that in this case, but as an example. If I just jump off this, I just have my default respawn points. So I will respawn in the center here. But if I have stood on this pressure plate, the code for it has run, and it's going to respawn me over in that other corner over there. Because it doesn't respawn me at the pressure plate, it respawns me specifically at where I placed the arrow that corresponds to this pressure plate. So that's a whole bunch of information about character death, character respawning, character teleporting, I suppose. And you can tell the more deeply we get into developing a lot of different stuff, the more you see, oh, there's actually like a bunch of different methods to essentially accomplish the same thing. And some things might be easier in one situation, some things might be easier in a different situation. And then as we progress through, another consideration for choosing the method of doing things is going to not just be the ease of working with it, but also the performance impact that things might have as they start becoming more complicated. For now, though, that's not a high priority. For now, all that we need to worry about is getting things done in the first place. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. My Cave Student tier supporters, Oiku, Earl, Monserville Erno, and my Cave Digger tier supporters, Mauricio Farias and Chang Dedu.